now it is the time for Q&A.
Yes, I was just wondering, how big is your operation, and how many computer programmers, and how many scientists, and how many business side do you have?
Yes, we are still small. We are at the moment about 18 people in Germany, and there's an increasing marketing network at the moment. Still, the technology is now on the edge. We really do to get used much more. We see this from the sponsor of the users, but it is not yet a standard. So that's the reason that I think also with the vision for this call, I think we hopefully realize that it's not far away to get accepted as standard. That's the reason why we now get introduced by European Commission to get these talks about how to introduce it by the agencies who are meanwhile coming to us and discussing their questions. So the market is not yet explored. That's the reason. But the other thing is that we invest a lot in fully operational processors. So that means to do this then on the worldwide scale, as we do now, we have essentially to install for the water quality processors some more the processors on top of the ground equipment. So that there's fully operational production.
Well, basically, what is the stability range?
The turbidity range?
Yeah. To what extent it can go?
Yes, I can give you here, because it's for turbidity, it's related not only with turbidity and suspended matter, but also with the absorbing components. So these all play together. So as a rough number, if you go beyond 3-4 milligrams per liter, then we cannot go beyond 5 meters, 4 meters. If this is extremely variable, also as is from that concentrations on it is usually, and it also gets more challenges. So we have at the moment here new pilot processors who corrects better for this variability, but it's at the moment in the test phase. So that means you have to accept for the moment being somewhere usually dependent on your requirements below these. But there are some users they are happy to get any information because in some regions of the world it's not possible to get anything. So then it depends on your accuracy requirements. Yes.
Do you only aggregate existing data sources, or do you collect new ground data at all? So like in situations where you're trying to do maybe a bathymetry or a habitat mapping study somewhere and there's no existing ground data, do you do ground data collection, or so far do you not?
Yes, so we as company very seldom go out to own ground measurements. Sometimes we do so. We work with Vietnam and Mexico, and also sometimes joint campaigns than in Europe. But from the processing point of view, the processing is independent on that. So that means if we configure the configuration, the processing for water depths, so here essentially we would be happy if we have some data, for example, of the reflectance of the seafloor, because this is the essential part to be configured manually still. So to get an impression, what is the range of bottom reflectivities for sands, for seagrass, and so on, which the model has to take into account. If we have some information, it's much better. If we want to go from these classifications then to habitats, we usually clearly need ground truth data to intercorrelate independent of the requirement of the client. If you just look about sands and biological coverage, then usually we don't need further information because the specific reflectance spectra differ already systematically. But if you want to, in more detail, analyze and maps and seagrass and coral reefs and so on, you usually have to combine this. Yes.
Thomas, when presenting those concentrations of suspended matter, to what extent are you also taking into account variations in suspended matter loads with depth? Because my understanding of many of these remote sensing products is that because there's a kind of relatively low reflectance from water, there's a high noise to signal ratio, it's very, very difficult to go deeper into the water column. And often there's great variation in water quality with depth, particularly in some of these environments, nearshore environments where there's a mixing of water of different salinities, etc., etc. I was just kind of quite interested in, you didn't tend to talk about the errors in these estimations, and I just wondered to what extent these numbers that you present truly reflect
Yes.
sediment loads.
Do you ask this with respect to which product? For water quality or for water depth?
For water quality.
For water quality? Maybe I didn't get the questions. Do you ask for the changes of the specific properties? For example, specific scattering properties may vary with the particle size distribution of the suspended matter, or which is the direction of your question?
Okay, so sorry, just when I was involved in some work with Sue Chin, actually, who's here in the audience as well. Hi, Sue Chin. In Sumatra, and so we were taking measurements of water quality, not just in the kind of surface layers, but also deeper down. And we were noting that there were some major variations in suspended sediment loads with depth.
Yes.
And so although we could create these algorithms which related in a reasonable way the surface concentrations of suspended matter to reflect its properties,
Yep.
they didn't really represent what was happening lower down in the water column. And so you could be underestimating heavily suspended matter loads if you're just measuring the surface.
Yes, well, surely, if you calculate the budget, full budget from this for rivers, you will have a large error. As you mentioned, you have tried a very high vertical variation of this. That's very sure. So the remote sensing only measures the surface concentration. So with these products, we operationally process also the depths where the signal comes from. It varies, for example, for very turbid waters between 1-2 meters, and in very clear waters up to 30 meters. So that is the integration of your measurement, of the remote sensing measurement. That means if you, as a river authority, want to assimilate this into your models, well, it's only the surface concentration. And your model, finally, the answer is that you have to combine it with hydrodynamic models in order to get the full view to the depth space, or the full budget in these cases. So it depends on the river system, how vertically stratified this is.
When you refer to time series data, so that's dependent on the satellite acquisition timing?
Yes.
Because you showed some time series data,
Mhm.
right? So does your product also do the interconnection or overlapping between what happens between the time zones? Let's say the satellite is measuring at 6 a.m. in the morning and say next day 6 a.m. So what happens in between? Is there some overlapping going on?
Yeah, that's a good question. It goes to the same direction as your question, because finally, to have a view to what is happening in space and time fully, you must integrate this with hydrodynamic or hydrobiological coupled models. Remote sensing gives you only a measure at that time when the satellite overpasses. Well, unlucky situation is that most times pass in the morning between 10 and 12, and there are few only who take the other direction of the orbit and then pass in the afternoon. You will not have sunlight that pass. Yes, you have. So if you could accept very coarse spatial resolutions of between 500 meters and 2 kilometers, you can also use for this geostationary satellites. So that means during the daytime you will have then measurements in all something like 50 meters, like meteosat. So meteosat is capable in principle. We didn't check it so far because most clients need higher spatial resolutions, but here it would be possible. Korea has a satellite, geostationary, that I think has 500 meter resolution, and so, but it is located over this region, would be capable for such application. Still, you have the limitations of clouds, so you have to come back to the hydrodynamic. So couple this with the hydrodynamic component. That's the reason why also in the EU project we try to combine this already. So we would like to go forward to combine this already as a service for users, that they don't not only get the measurements, but to together with models and has full well view to the systems that they are monitoring. You had a question?
Oh yeah, I did. So bathymetry mapping, when you're doing that, are you using time series data for that as well to make your bathymetry map, like a representative, more than just one image? Or is it just, do you pick like the best satellite image and come up with your bathymetry map?
Currently, it is that we pick up the best one, so I'd say 95% of the cases. Increasingly, we at the moment have another pilot processor that takes also multiple satellite images into account because it improves. Yes, so but it's in the test phase, so maybe may need some few months to do this. Depends then again on the cost, because to use a multiple high-resolution imagery can be very cost-intensive. If the client again then can accept maybe 30-meter resolution, yes, it's possible we need this.
And are you using only physically based models for bathymetry, or do you have some machine learning going on?
No, we only use physics-based. But of course, there's always space to improve. It may be that machine learning things may help us to more automatically derive the seafloor properties, which is the mineral step.
Any other questions?
Just a comment. This morning I did just some computations on the lake morphologies here, and the problem we have locally is a combination of two things. It's a combination of cloud disturbing the images, and the resolution of our in freshwater, the resolution of our reservoirs. Let's say it that way. There's only one reservoir that we have that has a maximum width larger than 500 meters. Mostly they are very, very narrow with max widths on the order of 250 meters. So you really need to depend on the higher end of the resolution of the satellites and have that co-occur with the cloud-free environment at the time,
Yes.
which complicates things.
That's absolutely right. There's a good message behind. We have more and more of these kind of satellites. So you saw this example from Mekong. Also, it's quite cloudy. So integrating all the satellites and also taking those, taking each scene. So you will always have some breaks of clouds where you can look through. Of course, there is some physical limit also again.
Yeah.
But so integrating all these will help you. So we have now at the moment 2 Landsats in this space. We have Sentinels. We have Spot, Theos. I think we have about 10 sensors in space or more that are capable of this. Still, it is a little bit expensive because of the data policy of the private satellite providers, but this will change.
We're looking in the same direction, but the projects that we have currently ongoing is to actually use camera technology mounted on tall structures and using both multispectral and hyperspectral imagery and
Yes.
subsequent processing.
Yeah. That's a good way. Yes.
So to that end, the software background that you were showing, where you move your camera across pixels and it instantly creates these composite graphs, that's interesting to us.
Yeah. We did not ask for one restriction of remote sensing, so I just would like to get you aware of this.
Yeah.
So this is when you come here, especially in Singapore areas, so you have some regions are quite shallow. So that means if the water quality processor doesn't correct for this, the product is overestimates TSM and something happens with the performance.
Yeah.
So it's such an error source. I think it is. We can pass this over. So again, there's another version that we test that can correct for this impact if we have the bathymetry on hand, but we don't know yet the limits and also the limits. But it is one.
And to that end, the deepest reservoir we have has a max depth of 24 meters.
So it depends how clear it is. So the optical depth is essential thing that limits the
In terms of coral mapping, if we did the mapping for Syro ornamental reef, is your product able to distinguish between live and dead corals? Or
it is under.
I saw like you had coralline algae as well as one of the categories.
Yes, it is under certain conditions. I must say that the project that we had didn't especially look for this, so we didn't check about there. But there are many projects worldwide where this was a central point, and they did this with sunlight methodologies again. So the general answer is in principle yes, but the specific answer is yes, but there's a general limitation again that you cannot discriminate between all habitat classes that you would like to discriminate. So it depends on morphology and on spectral features. If they are similar, you cannot discriminate. So that's a general answer, but for most of those applications it works.
So for instance, if you have like a coral bommy that's actually dead but covered with algae, you'll be able to differentiate that from a live coral, from actual live coral.
When the algae have a different morphology and spectral reflectance as the living coral.
Yeah, my question is similar to the first question is besides chlorine and suspended solid, can you also make other parameter for like curry, ergo bloom, curry, seagrass, things like that?
Yeah, which parameter?
Other parameter, for instance, like curry of ergo bloom, curry of seagrass.
Yes. So even we started in research at the German Aerospace Center. We started 12 years ago with investigating this with multi and hyperspectral airborne sensors for differentiating different types of seagrass. And that worked. Again, it depends. So it was between different. I'm not getting the biological names of those types, but it is going here to the same restrictions that I mentioned to you. So you may not discriminate between all the different classes that you would like to have as a biological person, but you can discriminate between different on the spectral shape. It's not only the brightness, also the spectral shape shows some significant some systematic differences. Still, when we did this also over different lakes at that time, when you go to another lake which has a higher calcite concentration, then the specific reflectance feature changes. So that means here are also then limitations on the natural conditions where these kind of species grow.
What about in terms like in highly turbid environments, like for instance in Singapore, where you get very it's not like in Mingaloo where you get water. The water is so clear and you can see up to 30 meters depth. Here it's really, really turbid. How does that affect the accuracy of the reef or the habitat mapping?
Oh, strongly, very strong. So if you go to such cases, it may result that you just can discriminate between sand and non-sand. So non-sand may be benthic materials, seagrass, maybe. Well, you know these environments, they are very scattered. So that means inside of one pixel you have multiple different coverages of something, and together with the turbidity, this results that you get that you can work out the coverage of maybe two classes, so sediment, non-sediment, or three classes. And that's it.
So at this point, are all of your variables spectral, or do you have non-spectral variables that you're using in these models or in the future planning using these models?
Still, we use mainly spectral, but increasingly we have some heterogeneous parameters in the tabs for classification there. But these are then not on the operational processing stage, that's an individual processing, dependent on the region.
So the models are more localized in terms of different regions.
For habitat mapping, yes. Yeah, well, still I'm available here for further discussions.
Yeah.
So
Maybe I wanted to give a token of appreciation for your and tea or serve outside, you can have one-to-one interaction as well.
Yes.